Good morning to everyone. Today we're going to be looking at lesson 89. We're going to be talking about a couple different things. We're going to be addressing diagonals in a polygon. Also, we're going to be talking about interior and exterior angles that can be found in a polygon. Today we're specifically going to be addressing two types of polygons. One of them is a regular hexagon, which is a six-sided polygon, as well as a quadrilateral. So let's go ahead and get started. I'm going to, first of all, just go down to the bottom of my sheet here. I have, I'm going to erase that and start over. If I were to draw a quadrilateral, and I named it A, B, C, D, and I wanted to draw a diagonal. A diagonal in a polygon is simply a line segment that's going to pass through the polygon between two non-adjacent vertices. Okay, so we have this vertex here at C and a vertex here at A, and I've created a diagonal here that goes from one vertex to the next, and that is C and A are non-adjacent vertices, so a diagonal is the line that you can see going from C to A, which is crossing through my quadrilateral. Okay, so that is a diagonal. We're going to be talking about those a little bit more throughout the lesson. All right, let's go into our notes. We're going to go ahead and start with example 1 up here. So let me just kind of expand this so you can see it better. In your notes, if you would please go to example 1, and you're going to notice here that we have a regular hexagon. So we're going to, from one vertex of our regular hexagon, A, B, C, D, E, F, that's the name of it. So we're going to go ahead and name that. Let's go ahead and start here, A, B, C. Go ahead and label yours just like I am, D, E, F. Okay. So from one vertex of a regular hexagon, A, B, C, D, E, F, how many diagonals can be drawn? Okay, we could choose any one of those 6 vertices to draw our diagonals from, but we're going to go ahead and choose A just because that's the beginning of our alphabet. So we'll choose A. How many diagonals can I draw? Now remember, a diagonal goes across the polygon or through the polygon from one vertex to another, but they have to be non-adjacent. So if I start with A, I can draw a diagonal from A to E. Those are non-adjacent vertices. I can draw one from A to D, and I can draw one from A to C. I couldn't draw one, that wasn't so good there. I can't draw one from A to B because those are adjacent angles, nor could I draw one from A to F because those are also, whoops, I didn't mean to do that. Just wanted to get rid of that. Okay, so I can make 3 different diagonals going from vertex A. Okay, now I want you to take notice of something. What did we create here? I have 1, 2, 3, 4 triangles, don't I? By putting those diagonals in there, we have created 4 different triangles. Now I'm going to just kind of show you there's 6 angles inside our polygon or hexagon, regular hexagon. And remember, because it's a regular hexagon, what does that mean? That means that all sides are equal and all angles are equal. Now, think with me when we talk about the sum of the measure of the angles in a triangle, they're 180 degrees, right? The total of the angles in a triangle are 180 degrees. And I have 4 triangles here. So if I were to ask you, what is the total measure of the angles in my regular hexagon, how could we figure that out? Well, first of all, we have 180 degrees in each one of our triangles, and I have 4 triangles. So if I multiply that, I'm going to get 720 degrees. So the sum of the measures of my angles inside my regular hexagon total 720 degrees, always. Okay. Also, I want you to notice that each one of the angles can be accounted for inside all four of our triangles. Now C is actually acting as part of C is an angle in triangle ABC. It's also this part of it right here. This side of the angle is a part of triangle ACD. Okay, but the point is each angle is accounted for within each one of our triangles. Okay, so this method is true, it works. I want you to also mark here, just use some arrows. We'll just kind of pick A and B. I want you to write here, these are called interior angles. Those are just simply the angles that are inside our polygon. Okay, so let's go ahead and fill that in. Now we're going to move over to example 2. Example 2, we have a hexagon that's inscribed inside this circle. Technically, these right here, those vertices should actually be resting on the circle. I was having a hard time actually making that happen. So just kind of pretend with me that they are actually truly inscribed and touching that circle there. Okay, so we have a regular hexagon again, and we want to find the measure of each angle of this regular hexagon. Okay, so we're going to go ahead and mark our angles using these arcs. And what did we say in example 1? Let's go back over here. In example 1, we said the sum, this is the sum of all the interior angles in our hexagon, totaled 720 degrees. So if all of these angles total 720 degrees in here, that's our total, then what is the measurement of each one of those angles? We have 6 of them, don't we? And because it's a regular hexagon, they're all going to be equal. So we can simply take 720 degrees and divide it by 6 angles, and we would get 120 degrees. So each one of these angles is 120 degrees. I could go around and do each one of those, but we'll just kind of leave it right there. Okay, let's go down to example 3. Now we've talked about the hexagon, and actually we're not done with that yet, but the book actually pokes this quadrilateral in right kind of in the midst of this. So let's go ahead and address this too. This is example 3. What is the sum of the measures of the interior angles of the quadrilateral? Well, let's go ahead and draw our diagonal. I'm going to draw from here to here. Mine's not too straight. Actually, I don't like that. We're going to try to do that a little bit better. Okay, so there's my diagonal. It wouldn't have mattered. I could have gone from this vertex to this vertex as well. It doesn't really matter. The point is, I can see that I have drawn 2 triangles now in here. So we can use the same method that we used on our other example above, where we know that the sum of the measures of each one of my triangles is 180 degrees, right? Each one of these total, 180 degrees. In this triangle, I have 3 angles, and those 3 also total 180 degrees. So I have 2 triangles, each at 180 degrees. If I wanted to know the sum of the measures of the interior angles of this quadrilateral, I could take my 2 triangles, multiply it by the sum of those angles that are 180 degrees, and I would get 360 degrees for my answer there. Okay, make sense? All right, now I want to address an exterior angle. We talked about interior angles, and those are the angles that are on the inside of the polygon. Exterior angles are actually on the outside of our polygon. Well, how can that be, you may wonder? So first of all, I'm going to kind of draw some things here. We said that each one of this is a regular hexagon, and we've already established up in example 2, we've already established that each angle's measure on the inside of a regular hexagon is 120 degrees. Okay, each one of those. I'm going to give you the definition of an exterior angle. I want you to write this in your notes. Just put an arrow down here, and here's what I want you to write. An exterior angle is simply a supplementary angle to an interior angle of a polygon. Okay, that's the definition. So what does that look like? Okay, so watch what I'm going to do. I'm going to notice that I have a side here, and I'm just going to extend it out. And then I notice I have a side here, and I'm going to extend it out. And I want you to do this in your notes as well. Here's this side, and I'm going to extend it out. Here's this side, and I'm going to extend it out. Here's this side, and I'm going to extend it out. And then finally, my last side, and I'm going to extend it out with dotted lines. Okay, so you can kind of see that I've created some exterior angles. Well, what's the exterior angle? Well, if the definition is an exterior angle is a supplementary angle to an interior angle of a polygon, then let's think about that. What are supplementary angles? Supplementary angles mean that you have angles that total 180 degrees. So if I extended this line out here, and I know that this interior angle is 120 degrees, well then that must mean that this one has to make a total of 180. So the exterior angle would be 60 degrees. Now keep in mind, this is a regular hexagon. So therefore, each one of these is going to be 60 degrees. So what is the measure of each exterior angle of a regular hexagon? It's 60 degrees. Okay? I hope that makes sense. I hope that you guys enjoyed learning a little bit about diagonals and our interior and exterior angles on our polygons. Today we specifically stuck to quadrilaterals as well as hexagons, regular hexagons. So we learned a few things. We learned that on a regular hexagon, we learned that the sum of all angles in our regular hexagon are 720 degrees. We learned that we can break that down to the measurement of one angle within our regular hexagon by dividing it by the 6 angles, and we discovered that each angle is 120 degrees. We also looked at the sum of the measures of the interior angles of this quadrilateral in example 3, and we learned that the total is 360 degrees of all the angles in a quadrilateral. And then in example 4, we were able to identify and we learned a little bit about exterior angles in a regular hexagon. If you guys have any questions while you're working through any of your problems today, please feel free to send a note out on Edmodo. I'm going to be trying to come up with something live for tomorrow's lesson so that we can, is it tomorrow? I forget if it was tomorrow or Thursday. I have to look at my lesson plan, but I'm going to be trying to come up with a live lesson for you to be able to see me actually teaching again, and you can be following along and asking questions as we are working through the problems. Hopefully we can do that as a review sheet for our next test. So just stay tuned. I'll be sending your parents an email, so stay tuned for that. Thank you for watching. I hope you guys enjoyed this lesson, and I will talk to you soon. Have a good day.